In this video, we are going to discuss a very nice topic in mathematics known as set theory. Kindly hit the red button to subscribe to my channel. It gives you notification whenever a new video is out. Okay, so the topic at hand today is set theory, right? But before I give you the meaning of this set, I have to display a particular picture which you are going to look at it. After looking at this picture I'm going to display, you'll find out that you can easily define a set on your own. Okay, now take a look at this picture here. You'll find out that this picture is just okay, I shouldn't answer it for you. What general name can be given to the picture below? So what name do you think is suitable for this picture displayed here on the screen? Ponder over it as I give you another picture. Okay, so what general name is suitable for this picture displayed here? Look at the faces very well and see if you'll be able to detect some faces there. Alright? Ensure you are still pondering over this picture displayed here. Okay, now let me help you. The general name that can be given to the first picture is just the group of footballers, like you can see. Look at it here again. They are just the group of footballers. You can see your Ronaldo, Messi, Rooney, etc. There are so many of them. So they are just group of footballers. Okay. The name I think you can give to these can be maybe group of politicians or governors of states in Nigeria. I can see my dear Governor Chief Willie Obiano of Anambra State. Okay. Now, the general name that can be given to the first picture is just group of footballers, like I said, while the second one is just the group or set of politicians. You can as well call them the set of politicians in Nigeria or the set of governors of states in Nigeria. Okay, let's continue. Now, from the pictures, one can say that a set is just a collection of similar objects. When you gather objects that are similar, that are serving the same purpose, that are doing the same thing, that has a link, when something is connecting them, you can say that such sets, such group, are just set, collection. Okay, therefore, we can now define that a set is a collection of well-defined objects. This word, well-defined, is the most important thing, the most important phrase needed in the definition of this set. Very, very important. Okay, I'll tell you why soon. Okay, now look at why it's important. It is important to note that not all collections are sets. Not all collections are sets because I've told you that a set is just a collection of well-defined objects. So not everything you collect is a set. For the collection you've made to be a set, the collection must be well-defined. Alright? Now, for example, a group of good teachers is not a set because my idea of a good tutor might be different from yours. Someone whom I see as a very good tutor, to you, you may see that person as a very bad tutor. So a collection like that is not defined. And since it is not well defined, it is not a set. Because for collection to be a set, it must be well defined. Well defined in the sense that everybody must have similar idea and opinion about it. Okay? Let's still continue. In set, there is what we call set notations. Set notations. When you hear set notations, don't be confused. The set notations are just those symbols you use in represent certain things in set. For example, as you can see here, we have union. We use letter U to represent union. Look at this symbol here for subset of a set. This is intersection. We have not an element of, not a subset of, the null set or empty set. So these are few symbols used in sets. There are more than these. Okay? So whenever you hear set notations, just know that set notations are those signs and symbols used to represent or denote certain things in sets. Okay, we are going into the types of sets at this point in time. I want us to know the various types of set we have. Number one is just a finite set. When you talk about a finite set, what comes to your mind? A finite set is just that kind of set where you can count the elements. When I say elements, an element is just a member of a particular set. So when you come into a set and it is possible for you to count the members of that set, it means that the set is a finite set. A set whose element is countable, alright? Okay, now you can see the picture I displayed here. These are the sets of governors of states in Nigeria. You can find out that these governors of states in Nigeria can be counted. Of course, every state must have a governor. Therefore, the governors of states of Nigeria should be around 36. So since you can count that kind of set, it means that the set is a finite set, because a finite set is a kind of set in which the elements are countable. Alright? So we can count the members of the elements of this particular set. Alright? Okay, now we talk about the infinite set. Okay, an infinite set is just a kind of set in which the elements are uncountable. When you cannot count the number of elements in a given set, it means that that particular set is infinite. It is just the opposite of finite set. For instance, I have the set of even numbers. The set of even numbers we have are 2, 0, 2, 4, 6, 8, 10, etc. No one knows where it ends, so it's infinite. You cannot exhaust them. But when you talk about the set of odd numbers, here you have 1, 3, 5, 7, 9, 11, etc. You cannot count the elements of such sets. So that is why they are called infinite sets. So when the elements of a set are uncountable, it means that that particular set is an infinite set. Okay, there are other types of set apart from this finite and infinite set. We have a kind of set we call the empty set, or the null set, or the zero set. Okay, the empty, the null, or zero set. From the name, it is self-explanatory. When you come to a set and you find out that nothing is inside it, look at this set, nobody occupies that space. Look at it here again, nothing is occupying it. So such kind of set is called an empty set or a null set, a set with no element. Okay, now if you look at this particular set, you see that we can use a symbol called a /0 to represent this kind of set. A /0, nothing is present there. Okay, so these are the two ways you can represent an empty set. You can just make a bracket like this. Remember, the kind of bracket tolerated in set is just the curly bracket. The curly bracket. That is the kind of set we permit, the kind of bracket we permit in set. So an empty set is a set with no member. For example, now, if you come to your school as a secondary school student and you have no principal in that school, it means that the set of principal in your school is an empty set because nobody is occupying that particular position. Okay, we still have another kind of set known as the single set. If you don't call it single set, you are free to call it the singleton or the unit set. These are the names you can give to it. If you take a look at this picture, you see our beautiful and hardworking Honorable Commissioner for Basic Education in Anambra State. You can see her. And such position, only one person occupies it in Anambra State. Hence, the set is just a single set. It has just one member. So look at her, our beautiful, hardworking, Honorable Commissioner for Basic Education. The office is occupied by only one person. Therefore, that kind of set is called a single set, or a unit set, or a singleton. A set that has just one member. So when a set is having just one member, it means that that kind of set is called a single set. Single set. There are many kinds of sets, and I don't think we may exhaust them in this class, but let's continue. There is a set called disjoint set. When two or more sets have no element in common, they are said to be disjoint. That is to say, when you come into two sets or more sets, and you take a look at the content, the members of the two sets, And there is nothing you can see in one set that you can see in the other set. It means that that kind of set are disjoint set. A good example of this is, look at this set A. A is housing A and I. Y set B is containing E and U. You will find out that there is no element in this A which I can see in this B. Therefore, these two types of sets are said to be disjoint sets. Disjoint sets, sets having no element in common. Okay? Another kind of set is the universal set. From the name universal, it means the whole, the chief, the organ of the sets. If you talk about Nigeria, Nigeria is housing 36 states. Okay? Those states are contained in Nigeria. Therefore, Nigeria is a universal set of the whole states in her. So a universal set is a set that contains every other set under discussion. Remember, this word is very important, under discussion. So whatever you are discussing, the set that is the chief, the set that contains every other set in that discussion is tagged the universal set. Let it be known to you today that Nigeria, which is the universal set of the states in her, can also be a subset of a higher set. When I talk about Africa, Nigeria is no longer a universal set because Nigeria is still under Africa. That is why you must add, while trying to define universal set, that it is a set that contains every other set under discussion. That word is very important, under discussion. Okay, and the symbol for this universal set is capital letter U. We use capital letter U to represent universal sets. Okay. We have equal sets as another kind of set. When do we say that two sets are equal? So two or more sets are equal if they contain exactly the same element. If everything you are seeing in set A is also seen in set B, it means that sets A and B are equal sets. So two sets are equal if they contain the same element. Not the same number of elements, but the same element. You must see everything you are seeing in set A, also in set B. Look at these two sets. Exactly the same animal I'm seeing here is what I'm seeing here. Set A and B contains similar animals. Hence, they are equal sets. Okay, we have another kind of set we call equivalent set. Students are most times confused between these equal sets and equivalent sets. Equivalent sets contain the same number of elements, but equal set contains the same element. Okay, so two or more sets are said to be equivalent if they contain the same number of elements. For example, here you can see set A is containing 2, 3, 4, 5, while set B is containing A, B, C, D. You can see that set A contains 4 elements if you count them, and set B contains 4 elements if you count it. Hence, set B and set A are said to be equivalent because their number are the same. But for them to be equal, everything I see in set A must be seen in set B for you to say that the two sets are equal. So equal sets are quite different from equivalent sets. Now look at this slogan in mathematics. All equal sets are equivalent, but not all equivalent sets are equal. If a set is equal, if two sets are equal, automatically they are equivalent because if they contain the same element, they are containing the same number of elements. But equivalent sets cannot always be equal. For example, here, these two sets are equivalent, but they are not equal. For them to be equal, they must contain the same element. Okay? Now we have the subset and supersets. I'll just give you a brief explanation of these subset and supersets. You can see that Nigeria contains 36 states. The 36 states in Nigeria is the sub means under, is under Nigeria. While Nigeria, which is the chief, is the superset of the states in her. So subsets are under a superset. Okay. Then power set is just the list. When you try to list all the possible subsets of a given set, including that set itself and the empty set, you are getting the power set of that set. So we may extract these power sets in the next class. Okay, kindly brief yourself, kindly evaluate yourself with these few questions here to ascertain if you've actually learned sets properly. In the next episode of this set, we shall be discussing the operations carried out in sets.
Hey there. Subscribe to my channel. And also press this bell icon.